Hello everyone, welcome to the concept of comparison of tuned amplifiers. In the past videos I explained different types of tuned amplifiers like single tuned, double tuned and stagger tuned. Now this is a very important topic which tells us the comparison of those three amplifiers. So coming to the first feature, the number of tuned circuits. In the single tuned amplifier, we know the tuned circuit is 1. In the double tuned amplifier, yes, the double tuned amplifier consists of 2 tuned circuits and which are magnetically coupled. And in the stagger tuned amplifier, we have multiple tuned circuits. And coming to the coupling, there is no concept of coupling in single tune amplifier. Even if it is a cascaded stage of single tune amplifiers, there is no coupling. But in the case of double tune amplifiers, there exists magnetic coupling. And in the case of stagger tune amplifiers also, there is no mutual coupling. Actually, each tuned circuit is tuned to different frequencies. Coming to the bandwidth, single tuned amplifiers are of narrow bandwidth. And double tuned amplifier, we can get our required bandwidth by adjusting the coupling. Okay, the double tune amplifier has 3 different types of couplings: critical coupling, undercoupling and overcoupling. Okay, and for the overcoupling, you'll get broader frequency response. In that case, the bandwidth is more. And in the critical coupling also, the bandwidth is somewhat high. And in the undercoupling case, the bandwidth is less. So, you can adjust the bandwidth using different values for coupling coefficient K. And coming to the stagger tune amplifier, yes, it has a wider bandwidth and it is having uniform bandwidth, flat response. And coming to the concept of selectivity, yes, the selectivity is moderate in single tune. And the double tune amplifier, the selectivity is somewhat greater than the single tune amplifier. And in the stagger tune amplifier, the selectivity is less. Selectivity and bandwidth are inversely proportional. When the bandwidth is high, the selectivity is less. We explained it already in the past videos. Okay, so you can verify. Then, coming to the tuning process. And the single tune amplifier, the tuning will be by adjusting LRC for resonance. And in the double tune amplifier, we have 2 tune circuits. Both are tuned to the same frequency. Okay, but the tune circuit output depends on the coupling. Then coming to the stagger tune, each stage is tuned to different frequency. Now coming to the frequency response curve. See this, single tuned amplifier response curve. The peak is sharp and see the bandwidth is narrow. And coming to the double tuned, bandwidth is high and you have broader peak. Coming to the stagger tuned, as I said earlier, it has flat and wide response. Okay. Now coming to the applications. The single tune amplifiers are used in RF amplifiers and radios. Double tune amplifiers are used in IF amplifiers and communication systems. Staggered tune amplifiers are used in TV intermediate frequency stages and broadband systems. And coming to the design complexity feature. Obviously, the single tune amplifier design complexity is very less. It is very simple to design. The double tune amplifier complexity is moderate, and the staggered tune circuit complexity is high because you have to tune different tune circuits with different frequencies. Okay, so that is the reason of having high design complexity for staggered tune. Coming to the advantages of single tune, simple and low cost, and double tune is tunability and better gain, and staggered tune, flatter response and ideal for wideband applications. To the limitations or disadvantages, it is with limited bandwidth. Okay, and the limitation for double tune amplifier is sensitive tuning. We must take care of tuning because the two tune circuits must tune to the same frequency. And then coming to the staggered tune limitation is the design is very complex. So this is all about the differences between, or this is all about comparison between various tuned amplifiers.